Welcome to this explainer. Today, we're going to look at something you probably do, dozens of times a day, without even a second thought: sending a simple text message. We completely take it for granted, but right underneath our fingertips is this incredibly astonishing reality that we're going to unpack right now. You pull out your phone, you type a message. Maybe it's literally just one tiny word: hey. You tap send, and almost instantaneously, someone on the exact opposite side of the planet can read it. It honestly feels like magic, right? But it's not magic. Your message doesn't just beam directly from your phone into theirs.
Which brings us to the core mystery of our explainer today. Where does your message actually go? What exactly is happening between the precise moment you hit send and the moment your friend sees that it was delivered? In that tiny split fraction of a second, a vastly complex, totally hidden journey takes place. Today, we're going to track a single WhatsApp message from the second you type it all the way to the other person's screen.
Section 1. Locking the digital box. Okay, let's dive into this. Let's imagine you type out a message like, "Are you coming tonight?" To prepare this securely, WhatsApp uses what's called end-to-end encryption. The goal here is pretty straightforward but incredibly powerful. Basically, your message gets encrypted right there on your device, and it can literally only be decrypted by the intended recipient's device, no one else.
So instead of just tossing your readable text out onto the open internet, your phone completely scrambles your words into locked, unreadable data. It's kind of like taking a private letter and locking it inside an absolutely impenetrable steel box.
Section 2. Navigating the global internet. Once that locked box leaves your phone and hits your Wi-Fi router or cellular network, it doesn't just travel as one giant, clunky piece. Instead, the data is broken down into much smaller pieces called packets. Imagine taking a massive Lego model, breaking it completely apart, shipping the pieces in separate, smaller boxes across the country, and then rebuilding it at the exact same time on the other end. That is the basic idea behind packet-based communication. Every single packet carries little bits of info, helping the network route it toward its final destination.
Now, a really crucial point here is understanding the role WhatsApp servers play. Their infrastructure helps process and route that communication, sure, but transporting a message and actually reading a message are two entirely different things. Think about your local postal service. A delivery driver can easily move a sealed, locked package from one city to another without having any clue what's actually inside it. In the exact same way, WhatsApp securely routes your encrypted box through its infrastructure without ever having the ability to read your actual text.
Section 3. The digital wait station.
But wait, what if your friend is, say, on a long flight with airplane mode turned on? Well, your message doesn't just disappear into the void. Walking through this timeline, you can see WhatsApp basically acts as a temporary holding area. Your locked box just waits patiently at a digital station until your friend lands, reconnects to the internet, and then bam, the message is finally pushed through.
Section 4. Delivery and decoding.
Now, what's really interesting about this part of the process is those little check marks. When the encrypted packets finally reach your friend's device, they still just have a locked box to decode, right? We see these check marks thousands of times a day, but they're actually tiny tracking updates for that entire decoding journey. One gray check means it's on its way. Two gray checks, that means it reached the device. And those two blue checks mean the recipient's phone successfully used its unique cryptographic keys to unlock the box, rebuild all those digital Lego pieces, and finally display your message as completely readable text. Section 5. Speed and scaling up.
The craziest part? All of this routing, scrambling, and decrypting usually happens in a literal fraction of a second. But to put that into perspective, contrast a tiny text message with a massive 200 megabyte video file. When you send a large video, it hangs on that sending status for a bit, simply because there is far, far more data to chop into packets, encrypt, transport, and reassemble. It just takes a little more time for the network to move that much digital weight around.
Section 6. The hidden physical world.
You know, it's so easy to just think of the internet as this fluffy, invisible cloud. But when you hit send, your message is actually traveling through a monumentally massive physical infrastructure. I mean, it is zipping as pulses of light through fiber optic cables, bouncing between towering cell antennas, getting routed through global data centers the size of football fields, crossing massive network exchanges, and even traveling through heavily armored cables lying at the very bottom of the deep ocean. All of that incredible physical engineering is working together, globally, just so you can send a 3-letter text.
To summarize this absolutely epic journey, Your phone locks the data, networks break it down, routers literally shoot it across the globe through deep-sea cables and cell towers, and your friend's phone unlocks it. There's a great quote that says, "The most complicated systems often feel completely effortless." And it is so true. You literally just press send, and the entire world does the rest for you. So, the next time you see a text bubble pop up, just take a second to remember the insane global journey it took to get to you. Which leaves me with a question for you to think about. What other invisible digital journeys are happening all around you right now, completely out of sight? Start looking a little closer at the everyday technology in your life. Thank you so much for joining me for this explainer. Stick around because we've got a lot more everyday mysteries to unpack together in future explainers.